Hi, I'm Harrison Spain, and this is Discovering Engineering. What is engineering, you might ask yourself? I personally believe engineering is satisfying human need or want and struggles. The proper definition is that engineering is science to fix world problems. In engineering, we have four main disciplines. The first one would be chemical engineering. The second would be civil engineering, and the third and our final discipline would be known as mechanical engineering. Chemical engineering is basically using chemistry, physics, to make and design things that go through chemical changes during processing. Some examples would include new fuel for rockets, reactors, and booster propulsion. Others are medicines, vaccines, serum and plasma, and plastics, synthetics, and textiles. All important stuff. And then we come to civil engineering, which is planning, designing, and supervising the construction of facilities. Projects are variable depending on size, nature, and scope. Some natural examples would include bridges, highways, tunnels, dams, etc., etc., etc. List goes on and on. Now we come to electrical engineering, which is electrons through metals, electrical systems, motors, and generators. Yeah. We need those to support our luxurious lives every day. Mechanical engineering, our final one, which is using the principles of some examples would be, include vibration and the lubrication and uh, a subtopic of our four main engineering. An example would be industrial engineering. In industrial engineering, we design, improvement, and people, machines. It's an extension discipline because of the machines and mechanical things involved. Some examples to produce machines and the raw materials that come out of machines. The workforce to operate the machine, I mean, gotta have people to run it or it won't work. The removal of finished products. If the finish line doesn't clear, you can't make new stuff, guys. The maintenance. Machines won't run properly, and how much the manufacturer won't be worth anything if your profit's not more than what you put into it. Some uh, an engineering example would be automobiles. It's come a long way. Engineering has come a whole long way. The automobile engineering is a link off the mechanical engineering chain because it requires a motor, gears, bearings, and everything else one would associate with mechanics. The automobile industry has come a long way since the Oldsmobile was produced in 1901. The automobile has been a source of transportation since then. It once was completely mechanical, now it has a lot of electrical, like radio and your rear view cameras and all that, your AC. Usually we just roll the windows down, got some breeze coming through the windows, but now all that's involved. Now it basically runs on a motor, gears, and a bunch of more stuff that you would consider to be under the hood. Engineering tools for the future of scientific discovery. Uh, this is something that will surely come later on. They are tools that could introduce the world to more and more scientific discoveries. Important because they are always questions to be asked, and every question, as you may know, has an answer. uh, production of specific tools could lead us further and further and further, and we could work harder, and they could be the solution to finding some unknown answers at the moment. It is the duty of an industrial engineer to design and produce machines. If he does not, we won't get a lot of stuff done. Who better than an industrial engineer could possibly design a tool that could change the world's science? I don't know any. And finally, here's our bibliography. I want to thank all these people. I want to thank the National Academy of Engineering. I got most of my information from here. The help of the National Academy of Sciences for giving me the challenges soon to come. And finally, I would like to thank Project Lead the Way for the PowerPoint that has helped me get through all of it. How do I stop it? Stop.